Let's go. Chapter 8. This chapter is on roles. Hopefully our Visual Studio Code plays nice today, because for whatever reason it was very broken last time, and I don't know why. Reload window. We want to be in here. Wonderful. And then we got to clean this up. Oh, I see. It shows up there. Nice, because I can click all of them now. Wonderful. So if you guys haven't seen them, we have this one, and that one. Yeah. So I made all three of those. I don't know if you've seen those, Benjamin. They're for the different tiers of sub. Hopefully you like them. I think they're cool. And then if you notice on the left, I put for 1 month subscribers. They're basically less than 3 month subscribers. I'm not sure if you saw those. Yeah. Things are blowing up, guys. We're blowing up. We're gonna be what is the other thing called? It is awesome. I'm very happy with this. This is very fun. Has arrived. What is this? What is this little one next to your name? Oh, you're the bits leader. Oh, cool. Okay, so we need some language extensions to do this. So we're gonna say role annotations. The scoped type variables. We know what that one's all about now. We have type applications, which I don't remember what that one is necessarily. Yeah, no worries, Benjamin. What's weird about it? I think they're always on the left of your name, right? So because you're tier 1, was that my gift to you, by the way? Or did you actually do that and that's why it was failing? I was trying to gift you one. In the sentence above. Which sentence? Because to me, I see it on all of them. Okay, so you beat me to it. Thank you. Thank you very much. I was trying to gift you one, because you kind of got the stream pushing along. So I appreciated that. That's probably why it failed. You beat me to it. Oh, that one. Okay. I see it on my screen. I can gift you emotes though. Actually, that's true. How would I do? I don't know how to do this, so. Yeah, okay. We can deal with that later, but we might do that. Okay, so we need coercible. And coerce. So this, that's the way we got that there. Import data foldable. It is so hot in here today. I am going to be sweating up a storm by the end of this. There's a space here. I like the space better because this means like all of the things in for some, right? And all of the things for product. Do we not get map? Containers. Got it. here, containers, this, save this, restart this. There we go. Okay, cool. What a crazy start to the stream, guys. Pretty fun. Okay, so in Haskell, new types are guaranteed to be a zero-cost abstraction. What that means is that under the hood, a new type has... Yeah, there might be a tool for that. I just don't know what it is. So a new type has exactly the same memory representation as the type it wraps. At runtime, there's no difference between a new type and its wrap type. The distinction between the two is made up and only exists in the type system. Given the following definitions from base, for example, I will do this. So new type, zip list, I'm going to do it in the style that I've grown to like. Get zip list. Okay, or I'm gonna put a prime on here because I imported everything from some. Nope. You know what? We should actually consider writing a tool for something like that. I bet you we could write a plugin that does something like that. Because like you could just parse the output of stack or something and say, oh, I found this very simple error that looks like this. Just add those things to package YAML and restart or something. We might be able to mod the modify the plugin itself to like just check it real quick and do something. Okay, so given these things, we can write the following. I'm going to ignore this because we already have it in scope, but it looks like this. So 54. I don't really know why I'm picking the exact same thing. But anyway, sum 54, sum 46, zip list 54, 6, and D zip list sum 54 sum. Okay, so all of these A, B, C, and D in memory are exactly equivalent because the wrapped list consists of the same bytes in memory as the unwrapped counterpart. Okay, so this is transitive, so because these are equal, these two things are equal, this is also equal, or I'm sorry, these two things are equal and these two things are equal. That means these two things are equal, I believe, is the way transitive properties work. The zero cost property of new types has profound implications for performance. It gives us the ability to reinterpret a value of one type as a value of another and do it at O to the 0 time. This can be performed via the coerce function. So let's look at coerce. Coercible. Okay, so that's the coerce function. The coercible A-B constraint is a proof that the types A and B do in fact have the same runtime representation. Unless explicitly prevented, discussed later, a new type is always coercible with its underlying type. Coercible is a magic constraint. The compiler will write instance of it for you, and in fact insists on this. It's actually an error to write your own. Oh, okay. That could be. We were sort of talking about implementing the lambda calculus in Haskell today, but I don't quite know how this works. All right, so apparently if you try and define an instance like this, it will just fail. Manual instances of this class are not permitted. So this, you can't even define this instance, which is kind of weird. Coerce can be used to massage data from one type into another without paying any runtime costs. As an example, if we wanted a sum of list of ints, we could use the sum int monoid instance. Okay. Slow sum. I'm trying to remember what this is. Right, so we fmap sum, so we have a sum of int, and then we mconcat, which I guess just is like a fold with this operator. Is mconcat like folder empty? That's what I'm guessing that's what it is, but we can look real quick. Hang on. I don't think I have another, no. Tab open. Google mconcat. Fold a list using the monoid. So that's my guess is exactly what it is. Yep, foldar mapend empty, exactly. So I was correct. For once. Okay. So this is not, what it says here is this not entirely satisfying. I don't know why it's not satisfying. Why do you say that? Oh, I mean, it, like, you have to get, like, I'm just guessing what it is, right? If the type is, show me the type, there we go. If the type is some int to some int, what's the only way to make this work, right? The only way to make this work, this kind of thing, is some sort of reduction, right? Like, you could do head, that would be a reduction, but the only logical reduction here, if we're doing a sum, is to, I mean, it's kind of telling you that. But anyway, reductions, those sorts of things actually make a lot of sense to me. The stuff that doesn't make sense to me is like that rank and types chapter where we do these wild implementations. Yeah. I think this one's a little, I don't know. Again, I guess it's, for me, it's obvious, but that doesn't mean it's obvious for everyone. Okay, so this requires traversing the entire list with an fmap just in order to get the right monoid instance in scope. This is O to the n, right? Depending on how the list of, yeah, it makes me dizzy. It's really hard. This is O to the n we need to pay for no reason other than to satisfy the type system. In such a simple example, list fusion might optimize away this penalty, but then again it might not. And without looking at the generated core, we have no way of knowing. We know how to generate the core, but we don't really want to look at it. For comparison, we can instead use coerce to transform list of int into sum of int in O to the 0, not O to the n. O of n? Do you say O of n? So I think it's O of n, I guess, not O to the n. I'm not very good with O notation, but I know that it's a thing. But we can also write this like this. Okay, oh right, they call it big O notation, big O of n. I'm not very good with that stuff yet. Well, I've never really played with it, but you can do this. Coerce, if I spelled it correctly. So this coerce will get you to some int for free. So coerce here is creates big O to 0. Can you read the difference on the screen, or is that too small for big O of 0? Hopefully you can read the dot. But this happens in this isn't I don't know what the right term is. 0th order, like this is linear, I guess. I'm not sure of the terminology here. I'm doing my best. But this happens for essentially free because the compiler is only like tricking you into thinking sum is an actual type. It's really just an int at runtime. And I guess getSum is the same way. You're kind of just like the core that's generated must just be, well, I don't know what the core is, but essentially it's just doing some sort of fold over integers. Okay, cool. As a general rule, if you ever find yourself writing fmap how would I use coerce? That's the only way I can use coerce. I need to make it understand that I want a sum int, otherwise the types don't work. So I guess the compiler like this is, I guess, Hindley Milner, right, at work. I know that this needs to give me an int at the end, so it's smart enough to figure out the types. But anyway, I think if I get rid of this getSum, it will probably complain, right? I mean, I don't know what the complaint is. Let's find out. Oh, well, yes, because coerce, well, it doesn't, I can't even get types to work out here. What if I do... Oh, interesting. What if I try... Oops. I'm just wondering if it gives a different error if I try and like tell it what coerce is supposed to do. Yeah, okay, so if I tell it what coerce is going to do, I should get a sum int out, right? So actually this does work if I tell it, but I have to tell it that I want the coercion to work in this way. Otherwise, the type system just figures it out for me, which is kind of cool. Although maybe it's actually these role annotations that's doing it. I'm not sure. I'm not sure who it is controlling that. But anyway, that's kind of interesting. So coerce is smart enough to figure out its types. I'm guessing that's just the type system. Like it's not anyone special. Okay. As a general rule, if you see fmap new type constructor, it should be replaced. Let me put this on the other line so you can read it. With coerce, because essentially it's the same thing and you get it for free. Okay, unless the functor instance is polymorphic, in which case the compiler will complain and refuse to compile the code. Your runtime performance will thank you, and you'll be able to sleep peacefully with the satisfaction of a job well done. That's important. Satisfaction of a job well done. Okay, because coercible corresponds to representational equality, we should expect it to follow all the usual laws of equality. Reflexivity, coercible AA, is true for any type. So laws of equality, reflexivity. Let's put this coercible AA is true for any type. Symmetry, coercible AB implies coercible. So if you can coerce one way, you can coerce the other. Transitivity, given coercible AB and BC, oops, it's weird. Coercible AC. Okay, so there's that. By this line of reasoning, we see that it's perfectly acceptable to coerce a sum A into a product A. What do I have up there? D. So this is perfectly acceptable. Coerce 1867 sum right? Representationally, these are the same because an A is also, or a sum int is also an int, and a product int is also an int. So you get A to C, I guess, sum to product. Okay, that's kind of neat. The line of reasoning here is that both sum int and product int are new types over int, therefore they're intercoercible by transitivity. A natural question about coercions is whether representationally equal types are always safely interchangeable. They're not. To see why, consider the case of data map.map from the containers package. So map.kv is a, let me just put that here because we're kind of talking about it. So map.kv data.map. Well, actually, we can just write m because I think I've imported it qualified. Yeah, so we'll just write m.map.kv is a container providing map lookups with key k and value v. It's represented as a balanced tree ordered via an ord k instance. So if we look at the type of its insert method, insert, we'll see this is the point. So ord k to v to map kv to map kv. This ord k instance is required in order to know where to put the resulting v in the map. Consequence is that map kv's layout in memory is entirely dependent on the ord k instance that it was built with. That ord k instance. Normally, type class coherence prevents us from shooting ourselves in the foot by switching out the ord k instance in scope, for example. But coerce softens this invariant. Oh, I need to read that again. Hang on. The consequence is that a map kv's layout in memory is entirely dependent on the ord k instance it was built with. Normally, type class coherence prevents us from shooting ourselves in the foot, but coerce softens this environment. I don't understand what that means, but okay. For example, consider the new type reverse, which flips around an underlying ORD instance. Okay. Maybe in this example that will become more clear. So new type reverse what? Oh, right. Instance. Okay, so it's just flipping around this. Even though reverse A is safely coercible with A, it is not the case that map reverse K. Okay, let me write this. So, reverse A is coercible with A. However, map reverse. Okay, give me a second. Hopefully we're kind of back. Now I'm very concerned about the GHCI plugin because that shouldn't have happened. So here's this. Okay. Am I back? I should be back. Let me get this set back up. What the hell? So literally my computer just straight up froze. No, do that. Yeah, computer straight up froze. So that was fun. So let's see here. What do we do? Do we continue? What's up, Warren? Do we continue trying to use VS Code? Or do we not? Because clearly something is going seriously wrong. So there was a message in VS Code that suggested I had issues. So we might go to the Vim GHCI combo. So let's do that. So we will go here. Hang on, I gotta look at this real quick. Sorry about this. I don't really know what's going on. So we will go to the GHCI setup. Okay, so GHCI D exec. I always forget how to use this. Hang on. I think it's command is what it is. Yeah, -C. Stack GHCI. Okay. And then Vim here. Okay. There we go. So, can you read this on the right side? Once I refresh this, it should. There we go. Okay. So we'll go to this development setup for now. I don't quite understand what happened with my computer, but it pooped. It just completely pooped out on me. So sorry about that. Okay. The other thing this means is I don't have to stitch these two videos together in YouTube, I suppose. Discord message. Fortunately, Now it's going to show up twice, which is really obnoxious, but that's okay. Hopefully it doesn't piss anyone off. Here we go. So, and apparently we've lost some text, which is interesting. So, okay. So reverse A and safely coercible with A. However, VS Code, thank you so much. You know, we've had very good luck with that plugin as well. Safely coercible with map reverse K. Okay, so these things, I mean, is map a new type? Map isn't a new type, right? I don't think it is anyway. We can look, but I highly doubt it. Map, data map. Da, da, da. Wait, where's the definition of map? Oh, it's got to be in here, I guess. Where's the actual data type? Yeah, this isn't even a new type, so why is this pointed out? Maybe it's just as an example. Oh, sorry. This is not quite the way. I'm not sure why this is pointed out exactly. We just discussed that you can coerce. Okay, anyway, maybe there's something else. I'm gonna keep reading before I speculate. Notice, however, that the layout of map KV does not depend on V. We are free to safely coerce map KV as map KV prime to our heart's content. Thankfully, Haskell knows both of these facts and allows us to coerce only when it's safe. Okay, so let's see here. Well, what we can do is just open this up over here and write the following. Coerce let's not do this because coerce singleton this is totally fine. However, the following is not fine. Okay, so could a match type car with reverse car arising from a use of coerce in the expression. So wait, how does it know this? At worst, it will crash. Notice, however, that the layout of mapkv does not depend on v. We are safely to... How does it know these things? Does anyone know how it knows? Nope, wrong thing. How does it know you can't do that? I don't quite understand. I think I'm missing something. Is it somehow that when you reverse an ORD, it understands that the ORD instance is different than the original ORD instance? Is that why? I'm not really sure. It sort of understands the reverse ORD versus ORD thing. Oh, really? That's awful. You probably have to refresh. That might be why. Sorry. We've been up for a little while. 10 minutes as far as I can tell. Unfortunate. That's really obnoxious. I don't know what happened. It's not super obvious to me. But my guess is it has something to do with the VS Code plugin blowing up in memory. Because, you know, why not? That's what plugins in VS Code do, apparently. Well, actually, all IDE plugins that work with Haskell. Thus far, anyway. Okay, so somehow it must understand that these two things are different ORD instances, right? Like this is a different constraint than this one, because it's like ORD reverse of A instead of ORD of A or something. I don't know what the right... I don't know how the type system figures this out, but it knows the difference between these two and these two. I'm sorry, I guess these two. This one and this bool. And apparently it's because there's no constraint on V. I guess that's what it is. So you're safe to coerce it. Something like that. Not 100% sure, but hopefully that is relatively useful for someone. Okay, so the question, of course, is what... Oh, here we go. The question is, of course, what differentiates K from V? Their roles are different. Just as the type system ensures terms are used correctly, and the kind system ensures types are logical, the role system ensures coercions are safe. Every type parameter for a given constructor is assigned a role. Roles describe how a type's representational equality is related to its parameter's coercion safety. There are three varieties of roles. So K and V above are different, have different roles. Chromolumi, look at that. That's great. That pops up right on my screen too. That's very useful, actually. Chromoluminaire thank you for the Twitch Prime sub. How cool. I'm very pumped that you're here. I'm glad you participate and hang out in chat. So everyone thank I said Chromo, I think. Chrono Luminaire for this subscribe. Okay, so we have Nominal. How's it going? Wait, I thought that for the subscribers, you guys would have you have access to these emotes now too, so don't forget there's the yes, I do actually. I don't remember what it was for. Let me see if I can bring my brain to remember it, but probably not. I'm a pretty forgetful guy, unfortunately. But I do remember seeing your name before. Oh, could you? Oh, that's right. You showed me source code, but then said, "Don't look at that. It's in rough shape right now." And it was for proof checking. That's what it was for. Bam! Look at that. I'm pretty sure that's correct. Anyway, you'll have to tell me. So nominal role. I think so. Is that correct, Chrono? Yeah, there you go. I can't believe I remember that. So this is the everyday notion of type equality. Constraint. Nominally equal to itself. Representational. The only thing I don't like about this is I can't scroll down like I could in VS Code. I like being able to put this up a little higher sometimes, but in Vim you don't really have that choice unless I start going like, you know, like that, which is obviously not particularly useful. But anyway, we'll just have to get used to it because I don't know what else to do. And B, yeah, that's actually what seemed to kill the stream. VS Code like just blew up in memory or something, because I noticed an error before, and the only reason I could think that the stream would blow up is that like the only things I have open right now are Google Chrome, OBS, and like, I mean, it could have been OBS that blew up. I don't know. It's not obvious to me, but there was one error in VS Code that was like, oh, it took a long time for GHCI to give you types. Do you want to see this message again? And I was like, no, or disable the plugin. So the only thing that gave me, or the only thing that was suspect before we went down was that. So that's why I'm using Vim for now. Types A and B are representationally reinterpret. Oh, I'm missing an R. Okay, so it's really just like the memory needs to be phantom. That's a weird thing to say. Okay, so I missed a chunk of this stream. Can you please explain what the role of coerce is in this map function? Absolutely. So the point of this was that this is perfectly acceptable. One can coerce a Boolean into a reverse bool. Okay, that's totally fine. However, if you try to coerce a S into a map reverse car as the key instead of the value, this fails. So I can quickly 64. I can quickly do this. Okay, so this fails, and the reason it fails is because, well, it's not obvious why it fails. Even when you look at this, it's not super useful to me. But the reason these fail is because of their roles. So the true and reverse, bool and reverse bool are representationally equal to one another. So it's safe to reinterpret a true as a bool. However, for some reason, the K here, i.e. S reverse car, inside the map, are not nominally or representationally equal. They're only phantom equal. So you can't reinterpret the memory of one into the other. And I assume that we're going to get into the, like, how do you determine if something is only phantomly equal to one another? Or if they, how do I say that? If their roles mean that they're only phantomly equal, I'm not 100% sure how we say that yet, but we'll get there. So anyway, these two things here cannot be, they are not representationally equal. Map car bool versus map reverse car bool. However, map car bool and map car reverse bool are representationally equal. Does that make sense? I still don't know why. I just know that they are. So we're getting there. Hopefully that's helpful. Okay, let's keep reading. Maybe we'll get this. So in the new type sum A, yeah, welcome, always. So given sum A, we say that A is at role representational. Okay? Which means that if coercible AB, fat arrow, coercible sum A, sum B, that sum A and sum B are representationally equal whenever A and B are. Okay, let me write this because that was a mouthful. Coercible AB sum A and sum B are equal. Okay, so let's read this again. So given sum A, we say that A is at role representational. Coercible AB, fat right arrow, coercible sum A and sum B, that sum A and sum B are representationally equal when A and B are representationally equal. Okay, I'm okay with that. This is also the case for V in map KV. However, we've seen above, coercible K1, K2 does not imply coercible map K1. Yeah, let me write this again. Okay. Sorry, it's really hard to say this in English words. K2V. And this is because K must be at roll nominal. K must be at roll nominal. Streaming God, thank you for following the stream. How are you today? I like your little symbol. It's really kind of hard to see. I can't tell if it's like a skull. Really hard for me to see in the little screen here. Thank you very much for the follow. Really appreciate it. We're blowing up today, guys. We're up to like 57 followers or something. We're doing well. The rich get richer, I think, is the term we're looking for here. The rich get richer. That's funny. Okay. So only when K1 is nominally equal to K2 can the two be coercible. Okay, but why? We say that A is in roll. So is it only the thing on the far right? Wait, why is it? I don't understand why this is true. This part was confusing to me when I read it before. Why is K at roll nominal? And V at roll representational. I was very confused by this before, and I'm not sure that I understand it still. Maybe there's going to be more here. Hang on. So the other role is phantom, and as you might have guessed, it is reserved for phantom parameters. For example, proxy, right? So proxy because coercible always true is not only is roll phantom okay, so it's not a property of But I don't understand. How does Haskell know that these two things have different roles? That part is still very much not obvious to me. Let's keep reading. Hang on. There's an inherent ordering in roles. Phantom types can be coerced in more situations than representational types, which themselves can be coerced more often than nominal types. Upgrading from a weaker role, usable in more situations, to a stronger one is known as strengthening it. Yeah, no, I agree with you. This is pretty tricky. Okay, so but I think I understand this a little bit. So something that is nominally equal to itself is literally itself. So you know, this, we looked at this before as a type constraint. So you can say, I think you put that on the left arrow. So you can write things like this, if I remember correctly. What letter are we on? H-I. Oh, I need type gad t's. Hang on. Okay, so check out this. So because A is nominally equal to B, they're the same. So this is equivalent to you writing a gadits, exactly. I said gad t, didn't I? Thank you. These two things are equivalent, so you can write I equals id, okay? Representational means like G. Oops. See, like now I'm trying to type as if I was in VS Code, which is a little annoying, but that's okay. Okay, so you can compare these things and they're actually equal, I presume. We could double check it, but you can compare these things because some int and int are representationally equal to one another, which means that in memory, these two things are exactly the same. And I guess technically even behind the scenes, they're the same because they're not, you know, in the core, they're the same. They're only different in the type system. But anyway, these two things are representationally equal to one another. However, what I don't understand is the why I know that these two things are representationally equal, but this K, the K's are not, and the V's are. And it seems to me that you only know that at runtime, the way that representational is said. So types A and B are representationally equal if and only if it's safe to reinterpret the memory of an A and B. That's the part I don't understand. How do I know the difference between K and K2 and V? Why are those different? But we're gonna keep going. Okay. So let me keep going. Just like types, roles are automatically inferred by the compiler, though they can be specified explicitly if desired. This inference process is relatively simple and works as follows. So hopefully this will give us enough information to figure this out. And then another thing we should be able to do actually is say L should be true, okay? So I just wanted to prove that that actually works. It doesn't just compile. Okay, blah, 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 blah. Where was I? Yes. All type parameters are assumed to be at role phantom. The type constructor, okay, so inference rules. 1. Can you guys read this okay if it's at the bottom of the screen? I just want to make sure it's okay. I've gotten out of this habit and now it's hard to continue into it. I usually don't, I'm not adding stuff to bottoms of files as often anymore. I'm usually adding them to the middle. All type parameters are assumed. Yeah, okay. So I'm not, that's not like a weird thing then. I suppose we could turn off the GHCI plugin that we're using and just use GHCID, but that means we're gonna have to switch back and forth between multiple windows. Or I can just put GHCID off screen or something. I don't know. Let's not worry about it. I might need to upgrade some stuff here. Okay. All type parameters are assumed phantom. I can spell, I swear. Okay. That was interesting. The type constructor has 2 representational roles. Any type parameter the type all right. I'm not sure this has helped me. The type constructor arrow has 2 representational roles. Any type parameter applied to a arrow gets upgraded to representational. Data constructors count as applying arrow. Okay, this isn't helping me thus far. I feel like I'm not here yet. I'm still not at roles. Okay, let's try this. So, oh my gosh. I swear I can spell. What is the role signature of either AB? So we're applying a data constructor. No. That's not a, either is not a data constructor. And also, I don't know what a role is here, or a role signature is. What's a role signature? Is it just the one word? Okay, I want to write the other one. Well, we already know the answer to this one, but... Oh, maybe it's supposed to be like this? To Phantom? I don't know what this means for role signature. I also don't know how this one works. Does this count as applying an arrow? So is A and B representational? Or is B representational? And A is phantom? I really don't know. I'm just gonna look up the answers because I don't understand this yet. Does anyone understand this? I'm not. Wait, did he explain this before? No, but anyway. So this is type role. Is A like K and B like V? That's what I was thinking, but that doesn't look like it because both of them are representational in this case. But I think... I'm still confused, so give me a minute. We might get there. While it's logical that a gadget counts as an application of tilde, it might be less clear why types used by type families must be at role nominal. Let's look at an example to see why. I really want to understand the K. I don't understand the K. How does it know? I really don't understand. I'm still very confused by this. Okay, so they are representational because left is applied to A and right is applied to B. Okay. Okay. But how about V in this case, right? Because according to this, V is representational, but yes, yeah, I agree with you there. But how do we deal with V? Well, how do we deal with K? I guess because well, let's go look at the definition of map. I guess maybe there's. Oh my gosh. This doesn't help. I really don't understand. Because it doesn't look to me like we're applying a data constructor to K. It's right here. It's only nominal because it's told that it's nominal. So okay, so by the way, this is how you assign type roles. So if we're using Glasgow Haskell greater than, I'm guessing this is 7.08. I'm not really sure the syntax here, but it assigns the type role for you. So you have a nominal, you're nominal in K and representational in A. So I think that they're providing this for you. You can't infer this. If you were to infer it, you would have representational, but you are defining this via this what is this called? Compiler definition? Compiler pragma? I think it's a pragma. Yes, you can't coerce nominal. That's correct. You can only coerce well, okay, that's not true. Wait. You can only coerce things that are nominally equal. So that means that you can only coerce, hang on. Where's my example? You can only coerce car and car are nominally equal, right? But car and reverse car are not nominally equal. They're representationally equal. So you can't do this. Does that make sense? Right? Car is only nominally equal with itself. However, it's representationally equal with reverse car. But because of its type role, you can't do that. Bool is, well, it's defined in its type role. We should put that in here because this is super confusing without that knowledge, because you can't just infer it, I don't think. You don't just know that. I'm having a hard time with this. This is very weird. Okay. Yes, compiler directive. I think that you could just write, say compiler pragma, but I assume this implies that type roles were introduced after GHC 7.08. Okay, so let's can we get a, how do we get a, I don't know how we get the, if we can get an anchor to this. Probably not, because there's no underscore. So let's just copy and paste this. I think this should probably be more clear in the book. So type roles can be defined like the following. Because actually, let's put this at the bottom. Okay. So, yes, this is a little awkward, but anyway, type role, nominal, representational. And you have to decide that, apparently. Because if you were to just look at a naive map, map type, that is, this would technically be representational. I don't know how to print these yet, so maybe we can print them. After enabling role annotations, we're capable of providing a annotation for it to strengthen the inferred role. Note that it's only possible to strengthen inferred roles, never weaken them. For example, because the V in BST, oh, I'm sorry, let me show this. So I should probably double check the type. Oh, it's not type role phantom, it's type role proxy phantom. So data BSTV, is that supposed to be balanced subtree? Okay. After enabling X role annotations, we're capable, that's the this role annotations up here. Yeah, it might be, wait, binary? I'm not really sure actually. I'm not sure if it's binary or balanced. I don't know what the right term for this is. We're going to do the purely functional data structures book at some point, so we'll probably learn what this actually is called. But I am not an expert in data structures. So my guess is that these are only nominally equal. For example, because the V in BSTV is inferred to be at role representational, right? Okay, so let's... Right, it's inferred this way because why? Because it's applied to, a data constructor is applied to it, I guess. This stuff is weird. Okay. Yeah, so you can see here, right up here, that the role is correctly representational. However, you know, you can't call it phantom. You can only strengthen. Weakening. Did I spell that right? Yeah. Okay, so you can only strengthen them, you can't weaken them. So that's what we did with the K, which I guess is... Okay, well, this is a little complicated because, right, this is a... I don't know what this K is here. I don't know a ton about bin. This is the only place... Oh, that's just a data constructor. Anyway, this is weird. This is very weird. But this does answer the question. This thing here this would work. It would, you know, from a type standpoint because of the roles, but because this is listed as nominal, that's why this doesn't work. I don't think that that's entirely clear in the chapter, unfortunately, but I think we got there. So that's probably okay. So the question is, do we want to continue and start talking about chapter 9, or do we want to wait and put chapter 9 in its own YouTube video and then talk about, I don't know, something different for example, the project. I found out some information about the project. Which part? I'm guessing that the K is set to nominal because you don't want it to be coercible, because you can change the order of K and mess up your map. Exactly. Because the ordering of K is memory dependent. Yeah. You can't change the Ks in memory, is my understanding. But yes, you're definitely correct. Because they're not actually representationally equal. They are inferred to be representationally equal, however, they are not. It's weird, right? It's very cool, though. I'm having a lot of fun. So, no one has said anything about doing project-y stuff versus chapter 9, so we can just continue. That's totally fine with me. So, let's commit this code. Oh. Excuse me. Right. I definitely want to go until at least 9:30 because we definitely missed last weekend, so I don't want to cheap you guys out. Oh, we missed Thursday and Tuesday. What's today? And Sunday. My goodness. Okay, so source main. Right, source lib. Nope, that's not what I wanted to do. Okay. Oh, and actually, type families. So these things are why I need to make this smaller, clearly. I don't know how to do that quickly, but this is why. What was that? Servant works. So servant works because of these associated type families. Oh, I need to change. Whoa. Okay. Title is changed. Okay, let's return to our earlier discussion about printf. I don't even remember talking about printf anymore, but anyway. Recall the concern was that despite printf having a type that humans can understand, it has many bugs coming from our inability to convince the compiler about its type. One of Haskell's most profound lessons is a deep appreciation for types. With it comes the understanding that strings are suitable for only unstructured text. Our format strings most certainly are structured, and thus, as the argument goes, they should not be strings. But if printf's format string isn't really a string, what is it? When we look at the specifiers in the format string, we see that they're kind of type signatures themselves. They describe not only the number of parameters, but also the types of those parameters. For example, the format string, let me write this down, %C, %D, %D. I don't remember what C means. Interpreted in Haskell as a function that takes a character. So character. I'm gonna put a comma. Well, this is fine. Let's do it this way. It's gonna be a car, and then an int. Oh, I see. Hang on. So this is like that. But a format string is not only specifiers, it can also contain arbitrary text that is to be strung together between the arguments. In some earlier example, this corresponds to format strings like which is kind of like string to int to string, I guess. Oh, it's... Wait, hang on. Like int to string, but it's more like s to show number. I guess. Oh, sorry, show. Right, because s in this case would be an integer. Okay. Sure. After some thinking, the key insight here turns out that these format strings are nothing more than a sequence of types and text to intersperse between them. We can model this in Haskell by keeping a type level list. Yeah, the S is from the book. I'm not sure why it's S. I would probably just call it X, personally. Yeah, or I would be fine too. Yeah, something else. But anyway, S seems to be like string, which is not, you know, or in my head anyway. But I guess typically when I write strings, I usually write like XS or something because it's like a list, but whatever. We can model this in Haskell by keeping a type level list of types and symbols. The types describe parameters and the symbols are literal pieces of text to output. Yeah. It's more, yeah, it's like a logical thing here, but you know, whatever. Doesn't really matter how you do this. Okay, so now we need a handful of language extensions, which kind of is this book, we know that. Data kinds. Flexible instances. Kind signatures. So one thing that is a little annoying now is if we do this in Vim, I still can't get like a plugin to deal with this well. Although maybe we could find one real quick. Maybe we'll wait till 9:30 and then go try another. It does. You would have to call %h format something. No. No, that doesn't work. forget, how do I feed the current thing into itself? I forget how to do that. Hang on. I just don't remember how to do it. Like percent, I think it's a percent or something. What is this? Even close. It's not from standard in. Because H format takes a file name. I knew there was a percent in there, but okay, so ampersand percent. Oh, but that's like a literal. I'm super confused. Yeah, probably. Maybe I can't do this with the percent or the bang here. Whatever. We could create a function to do this, but anyway. Scoped. Let's actually do it that way to save time. Because we're wasting time. It would be nice if every time I saved it, it just ran it. I think you just write h format dot. Okay. Files formatting is different, override it. Okay, so it's just -w. So actually, maybe this was working. That seemed to do something. So let's okay, so that works. We just need to create a little macro or something to do it. Let me write that down. I need to work on this a little bit. So we're gonna have to create a better workflow for this. Like it would be great if, you know, on save run h format. It would be nice if we, and then it would be nice if we could do linting as well, but I don't really know how to do that here. But anyway, undecidable instances. So everything compiles, so those are all the language extensions. What else do we need? Imports. Data, kind, type. Hey, Benjamin. maybe one of the things you could do as a side project is to create tools for the ultimate workflow. Yes, that would be awesome, but I don't know that I can do that. I don't know if I'm smart enough to do that. Because, right, they would have to be in Vim, or we would have to contribute to, like, I don't know, one of those other plugins. I suppose we could do that. We are doing Printf, that's correct. I think. GHC typlets. While you were gone, we had a crash. VS Code decided to crash on us. It might actually be that we need an update. So, there was something at the beginning that says your plugins change on disk. Do you want to reload VS Code? But maybe our plugins are out of date with VS Code itself or something. I'm not even sure. Something weird happened for sure. Okay. So we'll need a data structure to store the format schema of a printf call. This can be done by building a binary type constructor, which is polykinded in both of its parameters. The goal is to build a type-safe, heterogeneously kinded linked list. Data. Oop. There you go. But yes, NewMate, I agree with you. We need to figure out a better workflow because the VS Code workflow apparently doesn't work. And I also feel really weak when I'm doing it. Not that my Vim is very good, but I think that we could benefit a lot from using Vim a bit. Okay. The colon less than symbol was chosen due to its similarity with C++'s output stream operator, but has no other special meaning in Haskell. Fine with me. Notice here that colon, I'm just going to call this we just want to call this C out for lack of a better term. Let's just call this C out. No, that's not. Let's call it what it is. Output stream operator. Because that's what it looks like. So if we look at its kind, yeah, see, another thing we don't get in here is any types, right? Well, that's not a good place to put it. We don't get any types. So it's really frustrating, actually, because we really like types. It makes life a lot easier. So indeed, output stream operator works as a console for a linked list. We can chain them together indefinitely and store everything we want at the type level. We showed two examples, but we'll get in here in a second. So because of our infixer stream extractor, how about stream builder? Or how about printf stream extraction operator? Well, that could be. Okay, let's call it. Let's just call it printf operator. Built? I don't know. I don't know what to call it. I don't know that it has a great name. Because of the infixr declaration, repeated applications associate to the right, as we'd expect. Armed with a means of storing our format schema, our next step is to use it to construct the proper type signature of our formatting function, which is to say, given a type, Okay. This sounds like a type level function. Sorry, I lost my place. So we immediately begin to think about type families. However, instead of using closed type families, which are useful when promoting functions from the term level to the type level, we instead will use an associated type family. Associated type, I need a drink of water, hang on. Okay. Thank you for bearing with me for a second there. Associated type families are associated with a type class and provide a convenient way to bundle term level code with computed types. Because type classes are our means of providing ad hoc polymorphism, associated type families allow us to compute ad hoc types. So I guess this is like metaprogramming. So type classes, ad hoc polymorphism allows us to compute ad hoc types. So I think this would be considered metaprogramming, yes? We'll talk about bundling term level code in a moment, but first we can define our associated type family. Okay. Here, we're saying we have a type class has printf a, of which every instance must provide an associated type printf a. Printf a will correspond to the desired type of our formatting function. We will construct it in a moment. While it's not strictly necessary to use an associated type family instead of a closed one, they're equivalent in power. The ability to take advantage of Haskell's overlapping type classes will greatly simplify our logic. In the name of implementation parsimony, I believe I had to look up that word before, and I don't remember what it means. Anyone remember what that means? You can Google it again. Pretty sure I Googled it before. Okay. We will say our format types will always be of the form a printf operator symbol. That is to say, they'll always end with a symbol. Such a simplification gives us a convenient base case for the structural recursion we want to build. Structural recursion refers to the technique of producing something by tearing a recursive structure apart into smaller and smaller pieces until you find a case simple enough you know how to handle. This is really just a fancy name for divide and conquer. So in our printf example, we will require 3 cases. Symbol. Type is any type, so Boolean or anything. Any type that's available in Haskell. It's a polymorphic type. I'm pretty sure that's correct anyway. That's probably not right. It's the kind of a type. So the kind of bool is type. No, I'm just saying it wrong. My apologies. So this comes from data kind, and yeah, it's the kind signature for this. So this thing has a kind of type. Sorry for that. Yeah. Ugh. And I cannot remember for the life of me what symbol is, so we'll get there in a second, I think. With these three cases, we can tear down any right associative sequence of the printf operator via case 2 or 3 until we run out of printf operator constructors. At that point, we will finally be left with a symbol that we can handle via case 1. Case 1 corresponds to having no more parameters. Here, there is not any type level recursion to be done, and so we should just return our desired output type, a string. Okay, so, right. Yes, thank you for that, Benjamin Franklin Scout. Yes. So any string is a symbol. I do remember looking at this, but it's been a while. And also I'm extremely forgetful, so we're gonna have to remember stuff as we do it. BFG. I don't know what you're going for there. What's the G? I can guess what the B and the F are. Oh, nice. I got you. I see where you're going there. BFG is kind of fun to say. Although I kind of like saying gout. I don't know why that's funny to me. It's very funny to me. All right, so this is saying given text, given printf text of this kind, give us back this type. I don't know what the right terminology is here, but we're learning. Okay, let's look at this one and go from there. Okay, let me read this again. We don't have a parameter available to consume, and so here we don't change the resulting simpler type of printf. Therefore, we define the associated type instance of printf as. Why do we not care about the text? Because we already know its type? Because it's a symbol, it's a type string, I guess? Because of this instance? So now that we have this text here, I guess that means we know how to printf it already. I think that's how that works. I'm guessing this is the more complicated one. Okay, so this is generating our functions. So we can do a parameter here is, again, like an int or a bool. So this is how we're building up our recursive function definition. Although it's, oh, okay, because in this case, we're not actually, right. In this case, we're going to build some sort of lambda that just inserts the string pieces into place. But our ultimate function type is going to be like, you know, int to whatever to string at some point. This is pretty weird thus far. Okay. Is everyone okay thus far? I'm not sure I'm 100% okay, but I feel like it might make more sense when we keep going. We're saying our formatting type requires a param and then gives us back a recursively defined printf a. Strictly speaking, the type kind signature here isn't necessary. We apparently don't need this because if it's not a symbol, it will fall through, I guess. Oh, or it will just infer it because of this, I guess. That's what it says. But it adds to the readability, so we'll keep it. As a general principle, making type-level programming as legible as possible will make you and your coworkers' lives much easier. Everyone will thank you later. Okay. Not that we've done this in a team yet, but that's okay. We can walk through our earlier example of this one to convince ourselves that printf expands correctly. Firstly, we see that int... Let me highlight this. This whole thing is this third type, right? We have a kind of type followed by a, which is just the rest of it, which means we expand our type to param printf a, or substituting int to printf of the rest of this, and then we hit symbol, so we skip that basically, and then we hit bool, so we get int to bool to string ultimately. Oh, the final, wait, where does the final string come from? Oh, it comes from here, right? This is how we end. I get it. Okay, I'm cool, I think. Oh, we can do this in the, here, check this out. Look at that. Bam. Into bool to string. There it is. Okay, neat. This is really cool. This isn't too scary. Whoops. Right, we're there. Is anyone scared by this? I mean, it's pretty weird, but... building the type printf a is wonderful and all, but producing a type without any corresponding terms won't do us much good. Our next step is to update the definition of hasprintf to also provide a format function. Okay, so we'll get there in a second. Because the reason this is failing is because we need to actually define those instances for the other cases. Okay, the type of format is a little odd and could use an explanation. Yeah, so just remember that proxy is just a type to keep track of this a, but we don't use it anywhere. So any proxy is, well, maybe this doesn't help you because we had trouble with that as well, but any proxy is phantomly equal to anything else. So a proxy int is phantomly equal with a proxy doesn't matter, bool or something, but it's just a way of keeping track of a type parameter without actually caring about what this thing is. Maybe that doesn't help, but it's a little, it's weird and used mainly in the type system this way. It's not used in real code, it's used in type level code. Not that I know of anyway. Right, like how would you ever know what this type is if you wanted to do anything with it? You have to put it in there somehow. Okay, let's keep going. So 2 is the proxy, so let's talk about this. We find a term of a type proxy A. This proxy exists only to allow Haskell to find the correct instance of hasprintf from the call site of format, right? So when we call format, if we don't know this type A, we're never going to be able to get the right printf. That's the idea. Hopefully that helps a little bit. You might think Haskell would be able to find an instance based on the A in printf A, but this isn't so for reasons we will discuss soon. Sorry, if you read that in the wrong cadence, it sounds really weird. The parameter A, or the parameter I'm highlighting now, is an implementation detail and will act as an accumulator where we can keep track of all of the formatting done by earlier steps in the recursion. Finally, we have our printf A. Recall that printf will expand to arrow types if the formatting schema contains parameters, and thus all of our additional formatting is hiding inside 3. Our instance definitions for each of the 3 cases can be updated so they correctly implement format. In the first case, we have no work to do, so the only thing necessary is to return the accumulator and append the final text to it. The hell is this? What is symbol val? Oh, sorry. I missed something. Known symbol text. Okay, so that's fine. Hang on, we don't know what this known symbol thing is, but my guess is this symbol val thing is, well, again, I can't look at its type, so this is very frustrating to me. Especially from like a showing you guys standpoint. Like I don't know what these things are. Not that this is going to be particularly helpful to read, but maybe it will, I don't know. Okay, this doesn't help me actually. Maybe it'll be explained here. Nope, no explanation of symbol val. Oh, maybe we saw this before. So the at is how we get access to whatever the, what is the at for? What are we getting access to here? Whatever the type of text is, which is string, I think. So we're, yeah, okay. So this is the actual type corresponding to here. So whatever the actual type is, right? Text has kind symbol. So whatever the type is here, which it should be a string, I suppose, is giving you this proxy string. Type application. We can look that up. Because I'm also having a little trouble remembering what these things are. I need, again, this is like one of those things where we're gonna have to practice. Type applications, Haskell. Let's see if we can find a better explanation for both of us, NewMade. You probably can't read this at all. Hopefully that's better. Right. Yeah. So this is giving us just the type definition for proxy. Yes. So we're saying this is basically a proxy of a proxy text, which I guess is just stringed in this case. Can we write that in here? What if we just write, hang on. Can we write this? Just to experiment a little bit in GHC? Yeah, okay, good. So can we write string here? No, it would have to be, oh, it's okay, it's polymorphic because it's not just string, it's any symbol, but I don't know how many symbols are possible. And you can't put symbol here, right? So that's the problem. The only way you would be able to do this is if you had this type applications thing. Really? Oh, that works? Man. I guess this is just like an A. Yeah, okay. Yes, that makes sense. We're just shorthanding this. So let's go look at some examples because, so if we do, we looked at this before, but it's been a little while, so let's look at it. So if you had show, you can parameterize A to something specific. So you can write like show int. Yes, I thought I did. Oh, right, there we go. So here we've parameterized our A to int, just to show you a simpler example, right? This versus this. So it just gives us an easier way to give us type signatures. Okay. And symbol val gives us the string representation of whatever the type inside the proxy is. Hmm? I am blown away again. Okay. Where are we at? Here. Here. Known symbol text. Symbol val. Proxy. Okay. So let's start here. So this is exactly equivalent to this known symbol from before. Could we actually use this? Can we actually write format? I don't think so. Okay, anyway, this is giving us the I already forget what I'm getting here. What's the point of this? Is an implementation detail and will act as an accumulator where we keep track of all of the formatting done by earlier steps in the recursion. Okay. I thought these were partially. I'm a little confused here. We're gonna have to look at this code again next week, I think, just to satisfy our brain pieces. Because these aren't partially applied, I don't think. But I would love to see the types. They help me picture all of this. Okay, let's just keep reading. Notice the parameter in our format function here. This corresponds to the parameter in case 3's printf instance. That parameter. That's fun to say. For any specifier, we use its show instance to convert the parameter into a string and append it to our current accumulator. The third instance, printf is a function. Yep. Which makes format take 3 arguments. Yep. Yeah. this means that this takes an additional argument. It's pretty tricky though. We'll try it out. BFG, have you used this to write actual code? Or have you just practiced with these quite a bit? Okay. Mostly just a lot of playing around with it. Fair enough. I mean, that's... Oops. Okay, so in theory we can write printf do we need to re-enable this? Supposedly this is supposed to work. Is this... No, it's not. Good call. Thank you. You know, that's a pretty useless error. Yeah, right? I mean, I don't know if you've seen this error before, like, and subconsciously remembered it, but, like, that's a useless error. Is this coming from type applications? Yeah, that's a rough error right there. Okay. Anyway. I guess because it didn't know what Proxy's type was. In the first argument, in the expression, I see. This T1 is the proxy type. You just said it. Okay, so we got to keep lookout for that. Can't apply expression of type. If this said proxy, then it would be really, really strange. But it can't figure out that that's proxy. Okay, that's useful. Hopefully we remember that next time. But that's a pretty weird one. Proxy. Oops. I probably have an error in here. Hang on. Proxy int plus int. Oh, this one's more obvious. Okay, there it is. That was a much better error. And then we can also do thanks, show. Ugh. I think we were talking. I don't remember who I was talking about this with before. The plus and 3. Hang on. The plus and 3. How are those? They're captured in this pattern. Okay, so they're looking for symbols. So if you have a symbol, you can just concatenate them together. So you only fall through the third one if there's a parameter like integer. So the reason those work is you're hitting this. And the strings are just appended because of the symbol val proxy at text, I believe. Because their kind symbol is exactly the text that you write in there. I think that's the way you say that. I hope I'm saying that correct. Like there's a promoted I don't know if that's the right terminology. Hang on. I think it's coming from here. But I'll be honest, coming up with a great explanation in words is going to be hard because I can't come up with a good one. Maybe BFG will help us out here. But I'm pretty sure that it's this that's letting that work. And this is the magic that gives you the pieces. Now, one thing we could do to make sure, or check if that's true, is do this. Check this out. I got an idea. Interesting. Okay, so right. So the reason this happens is because when it gets to here, like the rest, let's highlight this like this. Well, okay, let's do it this way. When it gets to here, it sees. Yes, you got it. Yeah, okay, you figured it out before I even need to explain it. Yes, this is the base case. So unless you put those same symbols around this, you wouldn't get that. So if we put them here, just for like, let's make sure our brains are working correctly. Nope. Then we would get them around this as well. Right? So, yes. Neat. Let's delete all this junk. Okay, I think we're done. Oh wait, we're almost done. Let's just finish this chapter. It works well on our first attempt, all things considered. One noticeable flaw is that strings gain an extra set of quotes due to being shown, which I sort of mentioned. We can fix this infelicity by providing a special instance of hasPrintf just for strings. Okay, so instance. Can you, can you write a function that deals with the proxy at, so you don't have to type it out? Can you write a function? Oh, in your version of GHC, it says that. That's hilarious. Maybe it was like the state of my GHCI or something. I don't know. Could you explain a little bit more about what you mean, NewMade? Because I'm not 100% sure what you mean. Can you write a function that deals with? Oh, okay. Printf prime. I see. Maybe. Oh, okay. We can try it. Oh, I think we're actually using. Oh, I thought we were using allow ambiguous types, but we are not. Okay, let's finish this because I'd like. As printf a. Oh, I'm missing. There we go. Printf prime. I'm gonna write that in here just for my reference as well. And this will require ambiguous Okay. Writing this will require flexible instances, but we already have that. And then that overlapping thing is kind of weird. We'd like to select this instance instead of case 3 when the parameter is string. Do I have to put it above it? Or is it because this is more specialized than this one? It uses this instead? Oh, interesting. What are we going to do instead? Out of curiosity. Do you know? I don't know if there's like documentation about that. That would be cool. Okay, so let's try this real quick. What's the one? It's this one that was the problem. Nice. Abstractions. It's a fun name. Okay. There's something to be noted about overlapping instances for type families. In general, they're not allowed. The reason we can overlap param A and string A is that they actually agree on the type family instance. When param is nominally equal to string, I think is the way you say that, both instances give printf param A to be string to printf A. What we've accomplished here is a type-safe version of printf, but by recognizing that C++'s format string is better thought of as a structured type signature. Using type-level programming, we were able to convert such a thing into a function with the correct type that implements non-trivial logic. This technique is widely applicable. For example, the popular servant library uses a similar type-level schema to describe web APIs and will generate type-safe servers, clients, and interop specs for them. Type abstractions are like lambdas, but for types. That sounds cool. Hi, Kitty. Okay, so I think we're done for the day. We've finished actually 2 chapters, which is pretty cool. We had only 1 stream failure, which is actually abnormal. We do pretty good for issues like that. 3 stacks. 3 stacks. Who's 3 stacks? Oh, yeah. This is the one he likes to be. If Benjamin Franklin hasn't met him yet, here's Andre. He's already antsy. But yes, 3 stacks. Andre 3000. That's hilarious. Buddy. He needs love. So we're gonna call the stream now. So we already have 3 subscribers, which is insanity. So BFG, NewMade, and Chronoluminaire, thank you so much. Like, that's so cool that you would want to give me money to watch this. I don't know why, but I appreciate it, and I appreciate you. So we will be back on today. I always forget what day it is. I think it's Wednesday, Tuesday. It's got to be Tuesday. My watch is dead. So we'll be back on Thursday for some first class families is what we're going to do next. I think what we're going to have to do is figure out, I don't think I've read this chapter yet. Anyway, one thing we're going to have to do is come up with some good examples of like, how do we implement stuff from this book so that we can practice, right? Because we're definitely running into cases where we've forgotten stuff from earlier streams. And then luckily we have Benjamin Franklin's gout to help us. That's really funny to say. See, there's certain cases where BFG is not as fun as Benjamin Franklin's gout. That's one of them. But there are cases where we're like, hey, how do we do this thing? We've done it before, we've seen it before, but we don't remember exactly what it is. So I kind of want to create like my own little quizzes, like quizzes to design for me to take, or really anyone, to help them with this book, like solidifying this book. So maybe we can talk about that more in the Discord. But that's definitely, I think, a good idea. I think that would be really helpful for some people, including myself. Oh, yes, I am very interested. Thank you. I'm going to start this. You the awesomest. We'll put that in there. Done. Nice. Okay. Finish chapter 9. Push.